So, what if a single, seemingly harmless app could unravel the security of an entire company? Today, we're going to dive deep and break down how attackers can chain together multiple, totally unrelated vulnerabilities into one devastating cyber attack. We're talking about a master Trojan that compromises a whole corporate ecosystem right from the inside out.
You know, this single line from a security report, it just perfectly captures the finality of the attack we're looking at. This is that moment. The moment an attacker gets total control, where every single security layer has been systematically taken apart. This is way beyond a simple breach. It's a complete and total takeover.
Look, we're not just going to list off a bunch of random bugs. We're actually going to follow the attacker's path, step by step, to see how they build what we're calling a master Trojan. It's a single, weaponized chain of exploits that kicks off with a simple lure and finishes with an absolute enterprise-wide compromise.
All right, to really get how this all comes together, we'll walk through the attacker's 5-phase plan. Think of this as the blueprint for a digital heist, starting with that initial lure and ending with, you guessed it, a total ecosystem takeover.
So where does an attack of this scale even begin? Well, it's probably not where you'd think. It doesn't start with some crazy technical exploit, but by weaponizing the one thing developers rely on the most: trust. Trust in their official tools.
So check this out. The attacker cooks up this harmless-looking Trojan app in Google AI Studio, maybe calls it a GitHub Security Auditor or something. A developer trying to be productive grants it access to their GitHub. And here's the trap. The app then quietly creates a private repository in the developer's own account. Inside, it plants a poison version of Google's Nearby SDK. That's just a bundle of code. And this poison version, it has a modified build script just sitting there, waiting to run the attacker's commands.
So how do they get away with this? Well, you can see right here, they're exploiting two key flaws in the supply chain. First, the build files are missing what are called integrity hashes. Think of those like digital tamper-proof safety seals. Without them, there's no way to check if the code is legit, so the attacker can swap in their malicious version and nobody's the wiser. Second, the build script uses an environment variable in an unsafe way, which basically opens up a perfect backdoor for something called command injection. It's like tricking the system into running the attacker's code as if it were a normal, everyday instruction. Okay, so the trap is now set in the cloud. The attacker's next move is to pivot from that online project directly onto the developer's personal computer. This brings us to phase 2, establishing a local foothold. And this is where it gets really slick. This is the zero interaction part of the attack. The developer literally just opens the Poison project folder in their editor. A helpful AI extension, Gemini CLI, automatically scans a hidden settings file and, because it blindly trusts a command in there, it just executes the attacker's malicious code. No clicks, no pop-ups, no warnings. And just like that, game on.
Now that they're on the machine, the attacker takes advantage of a super simple but absolutely critical mistake. A file with a permanent login token is saved with insecure permissions. See that 644? That means pretty much any program on the machine can read it. A secure setting, 600, would have locked it down so only the user could access it. This one tiny error basically hands the attacker the keys to the kingdom.
All right, now we're escalating to phase 3. With a solid foothold on the local machine, the attacker aims for one of the most fundamental security barriers we have, the browser sandbox. You can think of the sandbox like a digital quarantine zone. It's designed to keep whatever a website is doing from spilling out and affecting the rest of your computer. To break out of this quarantine, they have to defeat this incredibly tough defense called MiraclePtr. This is a critical security feature inside Google Chrome, and its whole job is to stop a nasty type of bug called use after free. That's a memory error that leaves a tiny window for an attacker to inject their own code. For years, these bugs have been a goldmine for hackers. The precision required to pull this off is just astounding. The attacker has a window of about 1 single microsecond. That's a millionth of a second. They have to corrupt a specific piece of memory in that tiny window before the protection locks it down again. It's the digital equivalent of slipping through a closing bank vault door right before the lock slams shut. And here you have it, the payoff. This is a line taken straight from an actual security log. MiraclePtr status bypassed. They did it. They defeated one of Chrome's most advanced memory protections. The vault door is wide open. So why does this matter so much? Well, by escaping the browser's sandbox, the attacker can now steal the master session cookie. This thing is effectively the master key to the user's entire Google account.
And stealing it completely bypasses things like multi-factor authentication. It's a total compromise.
Now we're at phase 4. The attacker has control of one developer's account. Now they're going to leverage that to spread across the entire organization by weaponizing the very AI tools that are supposed to make everyone more productive.
This is just deviously clever. The attacker makes a normal-looking Google Doc, but they hide a malicious instruction deep inside it. Later, when a colleague uses their AI assistant in Gmail and asks it to reference that trusted document, the hidden command hijacks the AI's logic. It tells the AI to search the colleague's inbox for confidential emails and then forward them to the attacker. It's exactly like slipping a secret malicious note to a loyal, unsuspecting assistant.
And now we've reached the final, devastating phase. At this point, the attacker isn't just owning accounts, they're actively sabotaging critical infrastructure and jumping to completely different corporate platforms. This is the endgame.
First up, sabotage. They crash Google's internal API generator. Bam! That blocks critical updates to 42 different APIs. Then they inject a tiny error, just the simple string undefined, into a configuration file, which then causes over 150 consecutive build failures. This effectively stops Google from being able to ship security patches to fix the very holes the attacker is exploiting. And here it is, the final blow. Remember those browser cookies they stole way back in phase 3? The attacker uses them to pivot from Google's ecosystem into a totally different one. They hijack the user's active, logged-in sessions from Microsoft 365 and SharePoint. A compromise that started with a single Google developer tool has just morphed into a full-blown enterprise breach.
This chart really shows you the blast radius of this whole thing. It all started with a single point of failure, one developer trusting one tool. But from there, it created this cascading compromise that spread to their machine, then to their entire organization, and finally jumped into a completely separate corporate ecosystem. Each layer didn't just fall, it became the launchpad for the next, even bigger attack.
And that brings us to the big, final question. This entire attack chain was only possible because it abused the trust that's built into our systems. It wasn't about breaking down doors, it was about using the keys we handed over. So it really makes you wonder, when the very tools we rely on to build secure software become the weapons, where does the security boundary truly lie?